Hi everyone, really good to see you today. Matthew Kennedy here doing my Module 7 discussion board post 2. Hope you had a great spring break again. I know it's supposed to be about a paragraph or two, so we'll probably do about 4 or 5 minutes max. The one thing I'll say that we're supposed to do in this video is talk about essentially if I had to share something about calculus to a peer, friend, colleague, future student, what could I share about calculus that I took away from this module? And first of all, I'm going to be tying it a lot to Cook's book more than Rouse's book. And also, I'm going to be doing discussion board, the second video, which was about Professor Norman and the chalkboard stuff. So, from Norman's video, the one thing I took away was I'm not saying this is it with calculus, but there's really two ways to go about a problem in calculus. If I'm a student right now and I was given a calculus problem, there's probably going to be two different approaches to that problem. It's either going to be differential calculus or integral calculus. When we think about calculus as the rate of change, there's only so many different ways you can be going about that. Derivative, which is essentially kind of going forward with you have a particle's motion, then the velocity, the acceleration, triple derivative, which is above acceleration, you keep going, or you can go backwards with an integral. I can go from the velocity to the motion. And the one thing I'll say is, again, differential calculus is all about tangents of the curves. If I get a derivative at that point, it is the instantaneous speed at that time. We have integral calculus, which helps out with the areas, volumes, length of a curve. Again, area, volume of regions, bounded by a curve and all their stuff. So the one thing I'll really say, and also I want to share with my students, is it's not just differential calculus, integral calculus. It's if you understand how to do a derivative and you understand how to do an integral, you can pretty much get a good foundation of calculus. You can know every integral, every derivative, okay, sine, cosine, negative sine, whatever, right? You can know all these derivatives, all these integral rules, power rule, quotient rule, whatever. But if you don't know how to apply it, and you don't know, okay, what is the actual answer and what does that answer mean? And this goes back to modern algebra talk. I know Kim Rogers taught, Dr. Kim Rogers taught modern algebra to us. That's a big part for our students, is understanding what does that answer really do. So, watching the video, if you guys ever teach calculus in your future years, don't just say, okay, here's an integral, here's a derivative. Really get the students to understand what does that really mean in the context of this problem. And that brings me to my next point. When a student is given a calculus problem, do they know do they know what the question is asking? Okay, yes, you can guess, okay, I have a function here. I'm just going to gamble and say it's going to be a derivative, right? But we don't want our students to do that. We want our students to know, okay, that question is asking more about integral talk. It's saying that it's the velocity of this function, and we want to know, okay, well, first of all, what was, its placement at this time? Well, that is what the integral would be, correct? So, that's essentially a big takeaway I got from the video was there's really two ways to go about calculus. And there's more ways to go about it. Like, for example, in Cook's book, it talks about differential equations on page 387 with Leibniz. And then we also have Pascal, which is about chords, semicircles, other stuff in Cook's book. Binomial series about Newton. We have the max min, page 363 in Cook's book, which talks about, hey, I want to find the max and min of this function. Conic sections, page 359 about Fermat. So, and let's not forget about Cavallari, which is about infinitesimal values, finding the area volume of getting that, infinitesimal value to approximate, that integral. So you really think about what calculus is all about, and summing it up, It's the reputation it holds. Calculus today, especially when someone hears the words, oh, differential equations, oh. And, I just hear it so much, oh, Matt, what do you do in your life? I want to be a math teacher. And I hear everyone always say, oh, that's so tough and all that other stuff. But really, is it really that tough? Like, yeah, I get it. Math is tough to really master it. It's tough to get an A or B, whatever. But you can probably get a C with just having some foundational knowledge of, again, how to take an integral, how to take a derivative. We think about differential equations and how you separate the variables, x is on one side, y on one side. You then do the derivatives, right? And you really just think about what you're doing when you're really going about differential equations. One could really say it's just algebra and derivatives on steroids. That's what you're doing. Your algebra game of moving variables over, and then you have derivatives, you manipulate variables, you have an init condition, you plug it in, and you really think about what it is. Calculus is just algebra on steroids. It's geometry on steroids with shapes, curves, bounded by the curves, finding the area, volume, conic sections, other stuff. That's the big takeaway that I would tell a peer, colleague, friend, future student is calculus is a reputation. It's a reputation for difficult math. But when you really break it down, is it really that difficult? It's kind of like saying, oh, we have a huge fiasco here. We're having a family fight here. Well, guys, is this really that, like, should this really be escalated? Is this really that difficult to figure out? Or are we just making it more difficult than it needs to be? And that's how calculus is. Is it really that difficult? Are people, when they tell stories about calculus and other stuff, yes, it can be difficult. But at the same point, you really break it down what you're doing. It really is algebra on steroids. Have a great day, guys. Take care.